Um, the first video for assignment 6.2 is some general fossil fuel stuff. Remember that we're talking here about the rock cycle. We'll be talking about sedimentary rock, which is like stuff that washes off land, gets piled up in one place, and then gets squeezed over time into rock. Sedimentary rock. You know sedimentary rock because you live in Santa Barbara, and almost every rock that you'll encounter in Santa Barbara is sedimentary. And remember that fossil fuels are just an imperfection in sedimentary rocks. So usually sedimentary rocks are made of sediment. Organic material is usually removed from sediment by the activity of decomposers. So normally there's little worms that go through the sand to eat the little pieces of butterfly wing or whatever. But sometimes you end up with these layers of organic material trapped in sedimentary rock. These can form really special chemistry, hydrocarbons, a bunch of carbons stuck together. And if we can get that stuff out of the rocks, we can get the energy from those carbon bonds. Fossil Fuels 101. I want to start with depositional basins, any place in the landscape where things piled up. You can see in my screen any low spot. So it could be a river mouth. It could be at the base of mountains. Often you'll have what are called foreland or foreland basins, the middle of a continent, coastal areas. A good image of wetlands. Wetlands is a very important example. And a good image that might help you think about this is like the Santa Barbara Harbor. You know, any place where water slows down, things that are carried in water will settle. And maybe you know that the Santa Barbara Harbor periodically fills up with funk, and the harbor has to spend a ton of money removing all of that material 2 or 3 times a year. Depositional basins on any given day are just a place where things decompose and material gets recycled. So if this was an organic compound, a decomposer would break that up to release the energy from that compound. That's stored chemical energy. So the decomposer will digest and eat that, and then all these little pieces will be left over. Those are elements or nutrients, the basic building blocks of life. So if these were left in the water, maybe some producer would pick up those pieces to rearrange new organic compounds. And when that algae dies, these would be recycled by decomposers. This happens all the time. It's not the core of our lesson today. This happens in wetlands. It happens on the very surface of the organic material, the A, horizon, and topsoil. It happens out of the bottom of the ocean in those trenches where stuff deposits and there's decomposers that break up organic material. It happens in inland seas. And normally, there's really not a lot of organic material left because the decomposers are there to eat the organic material. So you have inputs of organic material and you have digestion of organic materials. So normally, if you add a little bit of sediment, that sediment will kind of settle, but then all of the organics will get picked out of it. And so when you add more sediment, the next layer of organics will get picked out of it. So normally, a depositional basin will have regular inputs of organic and sediment, but the organic is getting removed through digestion. Those worms got to eat. I want you to imagine a weird event. This is the rare and exceptional thing. I want you to imagine that somehow all of that organic material is somehow encased, it's trapped, it's entombed by some big deposit of sediment, mud, something. You could imagine a tidal wave hits a coastline and a whole cliff sloughs down and just buries a layer of organic stuff under sediment. Or trigger alert, you know, a big storm after a big fire. And you have a whole hillside worth of sand and ashes that all dump out at once. You can imagine like a change in geology so that a lake can break open and spill out all at once, and that would cause massive erosion and a whole big layer of sediment covers up that organic stuff all at once. The part that is unique is that usually the organic stuff is being skimmed off the top, but in rare cases, that organic stuff can be covered up by a whole bunch of inorganic stuff. You can imagine those worms would die. They're now buried deep underground. They can't get out. The little crabs or whatever were at the bottom just got covered up with so much stuff that they just smushed into like a layer, like peanut butter and jelly in a sandwich. And if you wait a really long time, like a really long time, more and more sediment will accumulate. And all of those little bits of organic material are combined with more little bits of organic material. And when you put all that organic material in one place, and then you start to apply pressure for like 100 million years, 500 million years, for like a really long time. You keep just randomly applying pressure. Every now and then, a piece is going to line up with another piece and it's going to click. And then a piece will line up with another piece and then it'll click. And so what you end up getting from that is a randomly assembled clump of ingredients. Because organic material is high in carbon, hydrogen, oxygen, phosphorus, nitrogen, the ingredients that you remember as our big six. Because organic material is high in some ingredients, the ones that dissolved into water are removed earlier on. The ones that don't dissolve into water often get clumped together. And by adding all that heat and pressure, you're assembling atoms into bigger molecules. If they're really high in carbon and hydrogen and oxygen, those are hydrocarbons. That's a lot of energy we can get out of it. So over time, organic material is compressed into much larger molecules that are primarily hydrocarbon. You can see on my shared screen, as you add more and more and more sediment, there's more and more pressure, so you get more and more bonds, and you make coal, you make oil and gas this way. Generally speaking, there are some interesting exceptions about how the ingredients affect what you're building. So usually we say that coal was made from small pieces of plant material. It's the lignin in plants. So when you take a plant and you grind it up, you get these little pieces of plant fiber. That's mostly lignin. It's a carbon compound that gives plants their structure. If you've ever seen like horse poop or like dried up cow poop, once they dry, it becomes kind of like fiber dust. That's all lignin. So we say that if you take all that lignin and you squeeze that together, a mostly plant fiber deposit would give you coal. And if there's a bigger blend of life, then that would give you petroleum and natural gas. This is a generally conceptual introduction, and we'll get to details later. So again, the thing I need you to know now is fossil fuels are basically a layer of organics that are trapped in sediment, and that's an imperfection. That's rare. 99 out of 100 sediments will only be rock, but 1 in 100 or 1 in a million or something will trap a layer of organics somehow, that sudden rush of sediment that sandwiches the organic material. And those get squeezed into hydrocarbons. There will always be a mix of fuels because some of those combinations of hydrocarbon will be more solid or more gaseous or more liquid. So all fossil fuel deposits have a blend of fuels, and you have to know that. And you also have to know that life has other ingredients. So when you're assembling hydrocarbons, sometimes an atom of mercury might get bonded into place, or sometimes an atom of lead might get bonded into place. There's a whole bunch of nitrogen bonded into fossil fuels. And whatever ingredients are in an organism, you probably have a couple atoms of gold knocking around in there. You probably have a couple of atoms of everything in the periodic table knocking around in there. So some of those might end up in a fossil fuel later. These are impurities, and this can affect the pollution you get later when you burn fossil fuels, and we'll come back to that. I'd like to just one last thing. I want to avoid confusion. I don't want you to assume that there's like a single recipe to make coal and then like a different single recipe to make petroleum. I need you to realize that there's always a blend of all three, and there's all sorts of chemistry and physics that affect whether it's mostly coal or mostly petroleum. There's like a bazillion details, but conceptually speaking, organic material squeezed together by pressure in sedimentary rock builds a whole bunch of carbon bonds. We call those hydrocarbons. Other stuff in there, impurities, blend of fuels. Conceptually, that's good enough for now. I'll be making more videos in a minute, but I think I want to stop and make sure I see everybody between videos on this topic.